Gas fitter exam cram session, video 26. So I'm looking at questions 27 and 30, and I could see where the code itself, permit holder and owner, the owner shall bear the cost and expense of inspections. Tests shall be performed by the permit holder. It seems to overlap a touch, but this is the exact wording of the code. And in this case, what I recommend you do is just learn it as is. Okay, the owner bears the cost. The permit holder shall do the tests. Okay, and the permit holder, like I said, could be the owner, could be the master plumber who obtained the permit on behalf of the owner. Okay, so question 30, permit holder shall do the tests. Department of Buildings or an approved agency shall witness the test. Question 31, it shall be the duty of the, once again, permit holder to cause the work to remain accessible and exposed for inspection purposes. Whoever's holding the permit, they got to make sure work that cannot be concealed before testing and inspection must remain open and accessible for that testing and inspection. The permit holder. This could be different people depending, all right? But at the end of the day, when they want to know, okay, why was this piping covered up? The person who has to answer the question, the one who's held liable, who's going to get blamed for it, is going to be whoever's holding the permit, who took out the permit for the particular job. It falls on them. Okay? It's their fault, ultimately. Question 32. Gas piping shall not be used as a grounding electrode. Okay? What does this mean? When you're running the domestic service, domestic water, it's a copper main, it's a metal main, usually copper main, comes in, from there, more copper, brass, all throughout the building, okay? If you notice, in the water meter room, generally that's where you'll find it. You'll find that there's a copper rod in the ground or a thick copper wire running into the ground, into the wall, and that is in some way, shape, or form clamped to the water service. Okay, this allows the entire water service to be a ground. If there's stray electrical charge, it'll go through the water service out into the earth. The earth can absorb an infinite amount of electrical charge, so stray electric current that could be a danger or a hazard just goes into the ground harmlessly. Of course, you need metal. Metal is a conductor. What's another metal line? The gas line. The gas line can be metal. It could conduct a charge, but it's got gas in it. Doesn't sound like a good idea. Okay? It's not a good idea. We're not going to use the gas piping, the gas service. We're not going to use that as an electric ground. In fact, we're going to do our best to break continuity in metal gas piping. If you ever notice, you go into the meter room, you have your distribution piping, the meter set, the control valve, you'll notice that there's dresser couplings, those big brown or black couplings with the rods in them. They kind of look like unions. They serve the same purpose as unions, but they're more like compression couplings. They got collars and you can screw them and they depend on tightening up. Inside they have rubber gaskets, metal reinforced, steel reinforced, rubber rings, If you ever look at the dressers closely, you'll see that wherever there's it's touching the pipe, there's also plastic collars and sleeves, insulating elements to it. It's to break up the continuity. At the dresser itself, if let's say there was a stray electric charge that found its way to the gas piping, it can travel it for some distance, but then that's it. That's the end of it. At the dresser, because of the insulation, the insulating elements, it's stopped. In the surface itself, I mean, they're running PE now, so that's an automatic break. But if you are using coated and wrapped pipe, so it would be steel, so you're running a steel gas service. To connect the steel gas service, you also use a dresser specifically for that application. You're going to run a wire and from one side of the dresser to the dresser's body itself, and then from there to the other piping going into the dresser. This wire, there's a special little tiny, you could almost call it a manual spot welding little device you can use, and it'll drop a piece of molten metal. You know, you're going to clean your surface until it's shiny. It'll melt it. You know, you ignite it, melts it just enough, drops onto each spot. So it's like it's spot welded to the metal in those three places, so that if there is a stray current running through the pipe, it'll go through the wire, jump through the wire, to the dresser, to the other wire, so that you have as continuity, so that the current will escape, go away. All right. At the dressers, you're going to break it with the insulating elements. For the service, you're going to take that charge and send it away. Okay. We'll get more to that later, because I believe in the code they still maintain that. They still talk about something like to that effect, and the actual gauge of the wire. There's a specific gauge for it. When we get to it, I'll go over it again. But for now, gas piping shall not be used as a grounding electrode. You hook it up to the domestic. So just make sure you don't mix up your domestic and your gas. Page 45. Okay, this is no, this is not the one. There's some more detailed questions. This ain't it, but it is the same number though, so this is good. So let me see. 35. 1 minute. No, it's not the number. All right, we'll just learn this as is. A low heat residential appliance is one in which the products of combustion at the point of entrance to the flue have a temperature of how many degrees or less? 1,000 degrees or less. Okay. This is from a section of fuel gas code, the appliance chapter. Okay. It's not a huge chapter where they draw a lot of questions from, but this is one question they drew from there. So you need to know it, because it's a number, not like the other numbers. So let's break this down. A low heat appliance. The code, the fuel gas code, is going to differentiate between a low heat and a high heat appliance. A low heat appliance is something. It is something that doesn't require the heavy duty or extra measures that a high heat appliance does. So where do they draw the line? The definition of a low heat residential appliance. So we said that the code sees boilers in a small boiler, small domestic boiler, or not a small domestic boiler, something big, industrial, commercial. And they drew the line at, well, what determines a small boiler? 350,000 BTUs input. Okay. Here, what determines a low heat or residential appliance as opposed to high heat commercial industrial appliance? The temperature of the flue. So this is not the input anymore. This is what's coming out of the appliance. This is our appliance. If it had been a boiler, the input can't be more than 300,000 BTUs. Okay? But the output, and what is the output? Well, I shouldn't even really say output, but it ain't the input, okay? The output would be the BTUs we're sending out. How about, we'll just say the flue, and the flue is not the input, but the exhaust being sent out from the unit, but the flue, okay? The flue is going to be judged not by BTUs, but by its actual temperature, because we're talking about low heat, so low heat is temperature. It can't be more than 1,000 degrees, okay? All measurements are given in our good old American measurements. When you look in the code, oh, this is just another thing. When you look in the code, this is from the International Code Council, so you're always going to see in parentheses next to any of the measurements that we know and are comfortable with, you're going to see the metric version. No tests I've ever taken give a rat's ass about the metric version. So anytime I mention a number, it's good old inches and pounds and degrees, okay? None of the metric stuff, so don't worry about that, okay? Yeah, so it's got to have a temperature of 1,000 degrees or less, right? So 1,000 is the limit to be a low heat appliance, all right? 350,000 BTUs input is a small boiler, a domestic boiler, a residential boiler. Residential is a better word. Residential boiler, 1-2 family boiler, residential. You know, residential can also be, we established R2 is apartment buildings. So apartment buildings, but a small boiler. You know, it would be kind of small for an apartment building, but 350,000 BTUs. What's R1? R1 is also residential. We didn't mention it because it wasn't really mentioned. It's not really mentioned in the fuel gas code, but R1 is nursing homes or, you know, care facilities. That kind. It's like an apartment building, but not an apartment building. It's like an institutional building, like a hospital, but it's not necessarily institutional. That kind of thing, like a old folks home or a hospice. You can't really call it a hospital. You can't really call it a strict apartment building. R1, that's what it is. R1 is that category. See, so a low heat residential appliance is one in which the products of combustion, in other words, the flue gases, the flue itself, you would take the temperature right at the hood, you know, stick your thermometer in there for the gases going up into the chimney. Can't go over 1,000 degrees, okay? 34, a medium pressure MP regulator. So we went over that, and where would we see the MP regulator? We'd see it in the meter room. MP, meter, M and M, okay? Low pressure regulator, it comes with the appliance. A medium pressure regulator reduces gas pressure from the range of greater than half a PSI and less than or equal to 5 PSI to a lower pressure. Okay, let me reread that because I'm sure I made it sound confusing. Okay, a medium pressure regulator reduces gas pressure from the range of greater than half a PSI and less than or equal to 5 PSI to a lower pressure. That is taken from the definitions chapter in the fuel gas code, and I think that was directly lifted. So I didn't change the wording. or the punctuation, and I just feel that sentence needs some punctuation. Okay, so what's it, just to make it a little smoother to read and understand. The NP regulator is so that whatever's coming in, after it's done in the medium pressure regulator, we're using this for cooking gas, so we want half a psi at the best, at the max, and generally we're looking for a quarter of a psi. So it's generally going to be calibrated to give us a quarter of a psi, but definitely to keep it from ever going above half a psi, right? So what does that mean? Well, if we already had half a psi coming in, we wouldn't need an NP regulator, would we? So whatever is coming in is going to be greater than half a psi, right? It's greater than half. Or else, why would we need it? We want to be at or less, quarter, right? Greater than half a psi, or it'd be pointless, and less than or equal to 5 psi. Greater than, less than, or equal to 5. So in other words, over half to 5 psi. Actually, wouldn't it be nice if they just said that instead of this? Yeah, over half a psi to 5 psi. Bring it down to half, right? Okay, so a medium pressure regulator reduces gas pressure from a range of greater than half a psi, greater than half a psi, and so a pressure range from a range of pressure greater than or between greater than half a psi. They really should rewrite this sentence. Greater than, yeah, so greater than half a psi all the way up to less than or equal to 5 psi, which in plainer English is, yeah, over half to 5. Bring it down to half. That's what the NP does. 35. Gas-fired, direct vent space heating appliances used for providing heat in rooms for sleeping purposes shall be deemed to be located outside of the sleeping room, provided that such a unit is factory assembled and manufactured with an integral factory assembled carbon monoxide detector interlock with automatic main gas shutoff valve. It's a lot of words. This is exactly from the code. This is from the appliance chapter. This has appeared in just about every exam that's been given. How do I know this? Because this is a question that guys keep coming back. And because it's so much wordage, they can't really say, they can't express the question clearly, but they always ask, what do you need off of this? Do you need a valve, a carbon monoxide detector? It's like, you need both, okay? You need a carbon monoxide detector. And interlock simply means that when whenever the safety device or the safety precaution, whatever kind of fail-safe you have, when that thing goes off, it shuts the fuel to the unit. Okay. When you go through the code, if you further exploration, you'll find that every time you have a safety this or safety that, especially when you're dealing with fuel, gas, or oil, all these things, they want connected directly to the fuel. They want the fuel shut immediately off at the slightest hint of trouble. The safety device, the safeguard, is interlocked. So interlock means the minute that thing senses a problem, boom, gas is shut off. Oil is shut off. Whatever the problem is, It cannot possibly get worse if there's no more gas, no more oil, no more fuel for that situation. So, gas-fired direct vent space heating appliances, what are we talking about? Okay. You can have a boiler in the basement, gas-fired, and it's going to be used for space heating, because if we have a hot water system, for example, a hydronic system, the piping is going to go up from the boiler to the baseboards, and through convection is going to heat the space heating. It's not the only way to do it. The blanket statement here, or implied, this statement appears in the fuel gas code. It doesn't appear in this question, but you're not going to have standalone space heating in a bedroom. Okay, where you sleep, you're not going to have fuel or oil-fired space heating equipment. Okay, and why? Well, you think about it for a second. Like I said, everything is fine when everything's working fine, but if for some reason something doesn't work right, the chance of carbon monoxide escaping, you don't want that at all. But now it's right there, right in the bedroom, right where you're sleeping in the same room. It's like you don't stand a chance. At least if, we have an issue with the flue in the basement, at the boiler, the carbon monoxide is there. Hopefully it shuts off the gas right there with the safeguard there. But if it doesn't, it's got to travel a bit before it hits a carbon monoxide detector at the entrance to the boiler, to the basement. And then if it misses that one, a carbon monoxide detector in the hallway, and then a carbon monoxide detector in the hallway on the second floor before it finally gets to the bedroom. That's a lot it's got to go through. If the appliance is right in the bedroom, you're fucked. Okay? Now, there is an exception to, space limitations, design limitations, etc. But you can have a gas-fired direct vent. A gas-fired direct vent means the unit is sitting on a wall, and this wall is an outside wall, such that within the unit itself, it's going to take its intake air and outtake air from the outside. Okay, this is an exterior wall. The unit is mounted. You got two holes, one for intake, one for outtake, so outside air. Okay, it's direct vent, meaning the products of combustion, it's combustion air is drawn from the outside. The products of combustion are also sent directly outside. So on the outside of the wall, you might see just like some kind of hood. Okay, and the air goes to the outside. That's a direct vent unit. Okay, you can see that. You don't really see that a lot in New York City. Everything's boilers and all that. But you can have that. There's such a thing for space heating. You can even have a fireplace like that. You can install a decorative fireplace and it'll work like that. It'll take its combustion air directly from the outside through the exterior wall, send it out right away. Okay? Combustion occurs in here. You got your heating elements to heat the room. You got whatever chamber to light your logs or fire or whatever. Boom, you can do that. That's a gas-fired. You can have it with oil also, but this one here, gas-fired, direct vent, space heating. So this appliance is not a fireplace. A fireplace is or decorative. The fireplaces don't really provide. They're not the most efficient ways to heat a room. So this one might have a blower in it. Okay, whatever heat you're getting, there's a blower, and it's going to blow it. So it's a forced hot air system per se, or forced hot air unit. This will not be considered to be located, procedure shall be deemed to be located outside of the sleeping room. Okay, this will, even though the mechanism that's blowing the hot air, heating the room, is in the room, violating, which might violate the blanket statement that we're not going to have any oil-fired or gas-fired appliance within a sleeping room. The fact that it's taking the air from the outside and sending the products of combustion directly outside. There's no flue coming up here. It's directly outside. They'll say fine. We're going to say we don't see it as being inside the room because the stuff that we are concerned about is being directly vented to atmosphere, mainly the carbon monoxide. If the unit is factory assembled, okay, and the unit is manufactured with or comes with an integral factory assembled carbon monoxide detector. None of this stuff is stuff we add on aftermarket. This is a one-piece unit and the safeguards are already built into the unit itself. Integral factory assembled carbon monoxide detector interlocked or directly wired to the automatic main gas shutoff valve. Whatever gas is being supplied to the unit itself has to have a shutoff in there. We could have an appliance shutoff valve. We could put one here, we're running the piping to it, but within the unit itself, there also has to be a shutoff valve. That shutoff valve, most likely a solenoid, because if we're talking about an interlock, there has to be some kind of circuitry involved. So the carbon monoxide detector is going to be locked, wired to the solenoid valve, which is an electrical valve, to make this connection possible. So when the carbon monoxide detector goes off, it shuts off the gas, regardless of the appliance shutoff valve, which you could also shut off, but the main shutoff, the main cutoff of fuel is going to occur within the unit because both the carbon monoxide detector and the solenoid valve are installed at the factory with the unit as one piece to prevent a situation where the carbon monoxide fills the room, kills everybody. Okay? So it's a lot of words, a lot of new stuff, but that's the gist of it. The main thing is the question, this is a direct lift. This is all the wording from that section in the appliance chapter. This is the question that you get on the exam. This is how it's going to look. This is the one that's been messing everyone up. Just remember, you're going to have choices. The choice you're picking is, it's got to have an interlock between two components. And these two components are going to be the carbon monoxide detector and the main gas shutoff valve. Okay? Automatic main gas shutoff valve, but well, yeah, of course, it's solenoid, it's electrical. It's going to be automatic. You cut the power, you cut the flow. So this question you will get. I know, like I said, I'm positive you're going to get it because that one, every test so far, I believe, they come back and that's a complaint. It's like, what do you have to have for blah, 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 blah. And they don't bring it back exactly understandable because that's a lot of words. Okay? But interlock between CO detector, shut off. Okay? 36. 36. Question 36. Service piping is all fuel gas piping, valves, and fittings upstream the point of delivery. So this sentence is asking, what is the definition of service piping? And rightly so, this question comes right out of definitions. So